Today's lesson, section 11.2a, we're talking about ellipses. So an ellipse is the set of all points in the plane, the sum of whose distances from two fixed points, f sub 1 and f sub 2, is a constant. So what that means is, if I have a ellipse, or an ellipse, and you have two foci, which is what they're called, so the two fixed points are foci, plural. So what they're trying to say is the distance, or their distance, from a point on the ellipse, the sum is going to be a constant. So this one, or this distance plus this distance, is going to equal some constant. Okay, and we'll talk about what that constant is in the next video, but you'll kind of see what it is gradually as we talk about them over the next couple days. But yeah, we're going to prove what that constant is in class. We're going to talk about the standard form for an ellipse. We're also going to talk about the Pythagorean theorem for an ellipse and a focal width for an ellipse. Okay, so all that stuff we're going to kind of put together so you understand how we get those things, and so they're not just kind of random pieces. So moving on, so an ellipse has two axes. There's a major axis and a minor axis. The major axis is the longest axis, and the points of the ellipse that cross this axis are called vertices. Okay, so the other ones are still intercepts, or crossing the intercepts, but they're not really that important. We don't use them that much. So these ellipses are going to be centered at the origin. So there are two ways that they can be oriented, just like a parabola: horizontally and vertically. Okay, so horizontally, that means your major axis, or your longest side, is on the x-axis. If it's vertical, then that means the major axis is on the y-axis. Okay, and you can note that that distance right there is going to be 2a, because it's from your middle to the vertices is a distance of a, and so adding both distances up gives you 2a. Okay, now notice that our horizontal equation looks basically the same, except for one little piece, is that the numbers underneath, the a squared and the b squared, switch. So when it's horizontal, the a squared is underneath the x squared, and the b squared is under the y squared. For vertical, the x squared has a b squared underneath it, and the y squared has a squared underneath it. Okay, so to know which one's which, because your a squared and your b squared are going to be kind of unique, in the sense that a squared is always going to be the biggest. That's what this thing is trying to tell you. So a is always greater than b, which is always greater than 0. So they're both positive values, but a is always bigger than b. So that means a squared is always bigger than b squared. Okay? So to know which one goes where, a squared is always the biggest, so it usually goes underneath the variable with whom you're like aligned with axis-wise. So if your ellipse is longest on the x-axis, your a squared should go underneath the x squared. If it's longest on the y-axis, then your a squared goes underneath the y squared. Okay? So just like we were saying, the vertices are plus or minus a comma 0 for horizontal, 0 comma plus or minus a for vertical. The major axis length is always 2a, no matter what axis you're on. Minor axis is always 2b, no matter which one you're on. Now remember, minor axis will always be opposite axis to the major axis. And then foci is going to be plus or minus c comma 0. And now here, notice that we kind of have a Pythagorean theorem going on, but it's a little skewed. So it's c squared equals a squared minus b squared, not plus b squared. Okay? And so we'll talk about how we get that tomorrow. Now, for this particular ellipse, this is kind of what we're looking at when we graph them in 2D. So you have your foci at c comma 0 and negative c comma 0, and then your vertices, You also have those other points, 0, comma b, and 0, comma negative b, but I'll show you how to kind of easily get these pictures so you don't have to work too hard, because I know there's like several points that we're using, but it's not difficult at all to graph ellipses. Don't worry about having a perfect ellipse shape. Notice that my pictures are not perfect. Okay? Now, another thing that happens with ellipses is something called eccentricity. So for either ellipse formation, so whether a squared is underneath the x squared or a squared is underneath the y squared, so whether it's oriented horizontally or vertically, your eccentricity, E, is going to be the number E equals C over A. So you take your C value, so focus value, divided by the A value. And just note that C equals the square root of A squared minus B squared. Same thing we talked about with the foci. So eccentricity for every ellipse is going to be satisfied between 0 and 1. So it's always going to be a value in between those two numbers. Now, as your E value gets closer and closer to 1, then that means your ellipse becomes more and more elongated. So it gets skinnier, skinnier, skinnier. Now, if it actually would become technically 1, it wouldn't be an ellipse anymore. You'd have a line segment between your two vertices. Okay? So that means also that your B value is 0 at that point. So then, but you no longer have an ellipse anymore. So that's why it doesn't go all the way to 1, but you can go pretty close. Okay? Now on the other side, if E is close to 0, then that means that the ellipse is becoming more like a circle. So the focuses, or the foci, come closer and closer to the center. So if they were to align on the center, or the center of the of your middle, okay, then that means that your foci have the same distance, or your center has the same distance to your vertices as your foci have to your vertices. And so that creates that radius, so then we have to become a circle and change our equation. So a squared is no longer greater than b squared because the two match now. So that's why we don't say that it's equal to 0, because it wouldn't be an ellipse anymore. It would be a circle. Okay? So now I want to be able to graph these. So I want to find my important information and then graph. So important information is to know which way it's oriented. So seeing that 36 is underneath the x squared, that means it's horizontal. Okay, so then that kind of helps us put stuff in the correct spots. So when I look at my vertices, now also I always like to figure out what A and B and C are first before you kind of move on. So A, just take the square root of your 36, which should be 6, because remember A squared is equal to 36. So it's an easy calculation you can do in your head. So the square root of 4 should be 2, which would be your B. So the other number is always going to be attached to your B squared. So if you want to find your C, then use your formula. So 36 minus 4 gets you 32. And so if I square rooted, that would give me, we would get 16, and 2 square root of 16 is 4. Okay, so now you have 4 square root of 2 as your C value. So if you want to know your vertices, remember it's just plus or minus A comma 0 for the horizontal ellipse, because all your main stuff is on the major axis, which is the x-axis, so that's the one that's going to be changing. So plus or minus 6 comma 0. Your foci, we found our C already, so plus or minus 4 square root of 2 comma 0. And then I want to be able to find my eccentricity, so that'll be your C value divided by your A value, I can reduce this a little bit and say 2 square root of 2 over 3. Okay? And then also, now, one quick second, because we do want a value in between 0 and 1. So let's type that in. So 2 square root of 2 divided by 3 gets us 0.94. So a little bit better reference. So since it's so close to 1, that means it's going to be pretty elongated when I draw this picture. My major axis value length is going to be 2 times your A value, which is 6. So it's going to be a length of 12. Minor axis length is going to be 2 times 2. So that gives me a value of 4. Okay. So now I have my graphs already kind of set up for me. So I want a graph. So we want to go out to 6 on our major. So since the horizontal is the major axis, that's where I put my vertices. So there's 1. There's the other. Now, from the center, I can also do the same thing with my B value, so I can get a decent perspective on my ellipse and how it looks. So since it's 2, I go up 2. Okay, and I go down 2. So that's where they get the distance of 2b. So that would be 4, and then 12 for the major axis. And so now for the ellipse, you just kind of connect the points. Okay, so you get your ellipse. Now I want to be able to graph 4 square root of 2 for my foci. And so that is about 5.65. Now I don't expect these to be perfectly where they're supposed to be, just get them in the right spot for the most part. So that foci should be here. You can still use 4 square root of 2 so that you don't have to write a decimal. And then same thing there. So negative 4 square root of 2 comma 0. Okay? And then that would be your graph. Okay? So you kind of do more of the heavy work at the beginning, but then the graphing part is pretty easy since you already have all your points set up for you. Okay, let's go back to letter B. So here, there's a little bit more to do. So anytime your equation is not how it wants to be set up, you just need to make sure that the right side is equal to 1. So to do that, I want to divide everything by 48, which would make that side 1. Now that means you also need to reduce your fractions on the left so that it's x squared over a number. So you get x squared over 6, and then plus y squared over 24. Okay? So now I can find my other stuff. 24 is the bigger number, and it's underneath the y squared. So that means that our axis, our major axis, is going to be vertical. Okay? Then from there, I want to do the same stuff that I did before. What's my A? What's my B? What's my C? So A is going to be the square root of 6. B would be the square root of 6. A, square root of 24, would get us 2 square root of 6. Okay? And then C, we do 24 minus 6. That gets us 18. Square root of that would give us 3 square root of 2. Okay? And so now I can find my stuff. So since it's vertical, my vertices are going to be the y-axis, so that'll be what's changing. So 0, comma, plus or minus 2 square root of 6. Your foci are going to be the same thing. So 0, comma, plus or minus 3 square root of 2. And then your eccentricity is going to be your C value divided by your A value. And here I want to be able to plug this in to find my decimal. So that gives me 8.7. It says 8.66, so let's round. So now I want to find my major axis, the length. So that's 2 times 2 square root of 6. So it gives me 4 square root of 6. And then my minor length is going to be 2 times square root of 6, which is 2 square root of 6. Okay, so now I want to graph those. Okay, so here I just want to go out a little bit so I can actually graph these. Now this one's not as elongated as the other one, but it's decently. So if I do my vertices, so I need to know what 2 square root of 6 is approximately. So that's about 4.89. So pretty close to 5. So there's one vertice. And here's the other vertice. Okay, do the same thing for your b values. So square root of 6 is just about 2.44, so it's almost to halfway between 2 and 3. Okay, so now you want to connect the points, make a graph, and then I want to graph my foci. So 3 square root of 2 is about 4.24, so closer to the 4 than the other one was. So focus will be 0, 3 square root of 2. And this focus will be 0, negative 3 square root of 2. Okay? And so those would be my graphs. All right? Have fun.